Hello, in this video I'll be talking about MySQL cluster. MySQL cluster is an extension to MySQL that allows you to create a database cluster with auto sharding and replication. MySQL cluster provides a new MySQL engine called NetworkDB or NDB. Typically, MySQL uses engines such as MyISAM or InnoDB, which manage the actual data storage. So let's look at some of the cluster roles in MySQL. So the most basic cluster role is the DB nodes. You can have multiple DB nodes. The DB nodes actually contain the data. They contain row-wise partitions of tables. This is basically horizontal partitioning and sharding of individual MySQL tables. Apart from the DB nodes, we also have the management nodes. Now, the cluster management nodes actually manage the cluster. It doesn't hold any data, but a cluster can have multiple management nodes for failover, redundancy, or data recovery. Now, the cluster management nodes will actually contact the individual DB nodes and make sure that they are alive, basically keeps the cluster in good shape. Finally, there is the API node. These are the nodes that actually access the cluster data. In case of a MySQL cluster, this API node is also a traditional MySQL server, but it uses the NDB cluster storage engine. API nodes are also called as SQL nodes. And API nodes will allow clients to access the data over port 3306. Now, once you have all of these three types of servers deployed in a MySQL cluster, you have a working MySQL cluster. So you need the DB or data nodes, you need the management nodes, and you need an API node which clients can connect to and communicate to the database nodes on your behalf. Now, you can have a system in which you have multiple API nodes in order to service additional clients. In this case, you would have an additional type of node known as the load balancer node, which can route requests to individual API nodes. So let's talk about how MySQL cluster actually partitions and replicates data among the DB nodes. So assume you have 4 DB nodes in your MySQL cluster. Well, one of the things that you need to configure when you set up a MySQL cluster is the number of replicas that you would like in your cluster. So for any given partition, the number of replicas you have will be denoted by this number that you provide when you configure MySQL cluster. In this case, we're going to say, hey, I have 4 nodes and I would like 2 replicas. So what happens then is MySQL cluster will designate one node to be a replica of another, hence you have 2 replicas, and that is going to be a partition. Similarly, for the remaining number of nodes, you also have the same arrangement. So since we have 4 nodes and 2 replicas, we end up with 2 partitions. So this is a fairly simple formula. The number of node groups or partitions in MySQL cluster is total number of nodes that you have in your MySQL cluster divided by the number of replicas that you define when creating the cluster. Okay, so now let's demo how to create a MySQL cluster. I'll first start with the actual web page in which you can download MySQL cluster. So if you go to dev.mysql.com/downloads/cluster, or if you just visit the MySQL website, make sure you go to community downloads and click on MySQL cluster. You can find the download sources for MySQL cluster. In this video, I'm going to work with version 7.4.7. And the platform that I'm going to be using is the Linux generic platform. So this will provide you with a tar.gz file. So installing MySQL cluster is not as straightforward as, a sudo apt-get install of MySQL server or MySQL client. We're going to do this manually on the instances that we're going to use. Speaking of instances, I have 3 instances that I've provisioned. The first one is the cluster management node. This is the one that sort of keeps track of all of the MySQL nodes as we discussed. The DB node is actually going to store the data in the cluster, and in this demo I'm just going to do one, but I'll show you some of the configuration changes that you'd have to make in order to support more than one DB node. And also I'm going to have a single API node. But if you have more than one API node, as discussed in the slides just before this demo, you're going to have to use a load balancer. So this is in a sense the most basic MySQL cluster that you can launch. For all of the instance types, I've used T2 small. This is because MySQL cluster tends to be fairly memory intensive, even if you don't store a lot of data. As the MySQL server processes start up, they pre-allocate a lot of memory, and you're going to need at least 2 gigs of memory on each of your instances. So, which is why I went with the T2 small instances. Another thing that is useful in setting this up is to check your security groups. So in this particular security group that I used for these instances, I have a all traffic security group set up, such that, you know, if there is any inbound IP traffic that is coming from any instance within the security group, allow it. So this sort of allows you to have communication between all of the instances that use the same security group, but using sort of like the private IP. So this just helps us and saves us a little bit of time in, you know, configuring specific ports that the management node uses to communicate with the DB node and the API node and so on and so forth. So I've done that. If you're trying to go through the steps in the video and you're having trouble communicating between these nodes as you set up MySQL cluster, just make sure you check your security groups and allow all traffic for all instances that are in the same security group on all ports and for all types of traffic, including TCP and ICMP. So what I've done here is I have all 3 instances. I've logged into all 3 of them. So I have the 3 individual tabs open on my SSH terminal client. So we'll start with the management node. Now with the management node, what I'm going to do is I'm just going to go ahead and download the MySQL cluster source files. Before we start, let me just move to root, because a lot of things that we'll be doing will involve us having root permissions. So the first thing I'm going to do is I'm going to go ahead and create a directory in the source user source directory, which will hold all of the source files for MySQL management. This is not required, but it's generally a good practice to have. So let's go ahead and switch to that directory. And what we're going to do is we're going to actually go pick up the MySQL files. So since we're running 64-bit instances, we're just going to go ahead and select the 64-bit version of the Linux generic tar.gz file that's already pre-compiled. If you just take the link address from the website, you should be able to wget the file directly onto your instance. So we're just going to go ahead and wait for that to download. Okay, so the download is complete. So I'm going to tar or basically untar these files. All right, that'll also take a few minutes. Okay, so the untarring is complete. Now what I'm going to do is I'm just going to go ahead and go into the extracted files, and I'm going to copy the binaries to user bin. This is going to help us in keeping all of the MySQL cluster binaries on the path, so that no matter what directory we are in, it'll execute. So I'm just going to go ahead and copy everything that's in bin ndb mgm. So this is the first binary that I'm going to copy to user bin, and I'm also going to copy the management daemon to user bin. So once we've copied these 2 files, I'm just going to make sure that they have the required permissions, 755, which allows them to be executed. So I'm just going to go ahead and say ndb mgm star. So both these files should have 755 permissions for execution. Okay. Once we have these 2 binaries, we actually don't need any of these files and folders. So optionally, you could actually have them deleted, but it's up to you. Now, so we've downloaded the MySQL cluster files, we've extracted them, and we've copied the binaries. Now we need to configure MySQL cluster on the management node. So what I'm going to do is I'm going to go ahead and create the default configuration directory for MySQL cluster. This is in varlib MySQL cluster, and we're going to change to that directory. Okay. Now the actual configuration file is called config.ini, and we're going to create this file from scratch. There should be a link to the actual contents of the file that I'm going to paste into this file below the video. So you can use that to basically copy these entire contents in. So just going to go ahead and paste. So it's going to contain a bunch of default parameters. This is a very important parameter, which is the number of replicas. Basically a MySQL cluster installation that uses a single DB node. I'm going to keep the number of replicas as 1, but as you increase and you want to have additional replicas, you can actually increase that number based on the formula that we just discussed in the slides. And this is the parameter for the memory that this is going to use, which is 1024 MB, and you need to have that much amount of RAM that is available to the MySQL cluster process, especially on the data node. So you need to have that, at least that amount of memory available to the process. So you need to have, you know, an instance with more than that amount of memory. Okay, so then we have individual sections for the individual nodes that we are going to set up. So the first section is going to be for the cluster management node, which is actually this node. So what we'll do is we'll go ahead and we'll set up the private IP address for this node. Okay, so I've pasted in the private IP address. So this is the cluster management node. In the next section, we are going to put in the IP addresses for all of the data nodes. So we have only one. So, but for each data node that you're going to have an additional section that is going to populate all of the IP addresses. Okay, so that IP address is now in. And finally, you're going to have IP addresses for all of the API nodes. And for each API node that you have, you're going to have an additional MySQL D section that you can see on the screen. Since we have only a single API node, I'm going to only keep one of those sections. But in the project, when you scale up and you're going to have multiple API nodes to process incoming cluster requests, then you're going to have multiple nodes. Okay, so I've pasted the API node IP address, and I'll just get rid of the other API node sections because we don't have any of those API nodes. So now we have this management node configured, and we can go ahead and start the cluster process for the management node. So the command to actually start the cluster management node is ndb_mgmd. Followed by the file name parameter f, which is your cluster configuration file that we just created, as well as a path to the configuration directory, which is the same directory that contains the config file. So the moment we type this in, you're going to get a message that says that the cluster management server is running. Now, this exact same command, if we want, we can actually go ahead and configure the current instance to run this command each time this is started. The best way to do this is using an initd script. So I'm going to go ahead and echo that command into an init script file that we're going to just create right now. So this is going to be in the etc init.d folder, and if you just give a name for this, and this is going to be the ndb mgmd, which is the name of this daemon. And also you need to make sure that that script is actually executable. So I'm just going to go ahead and say etc init.d and ndb mgmd gets chmod 755. So now not only did we run that command, we also configured the instance to automatically run that command each time this instance is started. So this is useful if you were to ever to stop the instance, you don't have to log it back in and run the command to start the server. It's going to start automatically as this server starts. So now what you can do is you can verify whether ndb management is actually working. So let's just go ahead and say ndb mgm, which is the client command, and this opens a shell in which you can issue a couple of commands. The most important command is show. Now show is going to go ahead read the all of the configuration files that we just set up, and it's going to tell you which of the nodes are currently connected. And as you can see, only one node is currently connected, which is this node itself, the management node, because we've not configured the other nodes yet. But hopefully as we configure the other nodes, they'll also show up over here. Okay, so now I'm going to switch gears to the DB node. Now in the DB node, we need to set up NDB, and it's a little similar to how we set up the management node. So we're going to repeat the same process. We're going to download and copy and install the necessary files to run the DB node on this machine. So the first thing I'm going to do on this machine is actually switch to root, because a lot of our commands will involve root access. Now once we are in root, we can go ahead and say that we want to switch directory to user local. Alright, so we'll go ahead and download the MySQL files directly to user local. Once the download is complete, as we did in the previous machine, we need to extract this file. So tar xvzf and then followed by the name of the actual file. Okay, the extraction is complete. Now I'm just going to go ahead and create since the extracted files are actually in a fairly long path, I'm going to contract that by creating a symbolic link. So I'm just going to say ln-s, and then we're going to create a link to this actual long folder, and we're just going to call this link MySQL. So we don't have to type that entire folder name each time we need to access the MySQL files. Okay, so now that that symbolic link is created, the next thing we're going to do is we're going to copy the binaries over to user bin. So I'm just going to go ahead to user local MySQL bin, and instead of copying, I'm just going to move all of these files. So I'm just going to move them to /user bin, and let's go back one directory to the actual MySQL directory. And just to avoid confusion for any applications that are looking for these binaries, I'm just going to remove the user local MySQL bin directory, because we moved all the files out of it. And instead, I'm going to create a symbolic link to user bin, and we're going to call it user local MySQL bin. So we replaced that existing directory to a link to the user bin directory that contains all of the binaries right now. Okay, so that link is now established. Now we've downloaded, extracted, and copied all the binaries for MySQL on this instance. Now we need to do the configuration of this instance. Now for any MySQL server, typically the configuration file is going to be located in etc/my.cnf, and I'm just going to go ahead and open a text editor so that I can edit the my.cnf file. Now the since we're creating this my.cnf file from scratch, I'm just going to go ahead and paste a few commands in here. This will be available in a link after the window, the same commands that I have in here. So the basic thing for this DB node is we need to provide the private IP address of the management node. So we can go ahead and paste that in here. And similarly, we have one more place where we need to actually paste the IP address of our management node. So this is basically going to be the my.cnf file that we are going to use for the DB node. All right, so the configuration is complete, and now all we need to do is create a data folder and start the database node, the DB node for MySQL. So we'll go with the default directory that MySQL uses for these things. So we're just going to go ahead and create a directory in var lib, and we're going to call it MySQL-cluster. And let's go ahead and cd to that directory. So this is going to contain the data, and as we launch the MySQL DB node process, it's also going to create some of the log files. So if you ever find anything that's not working, or if something doesn't seem to work, you can inspect the log files in this directory. So the command that we're going to use is ndbd -- initial. You only need to issue this command if you're going to do this for the first time. And we can look in the management cluster. So if you have a management client running, it will actually show you some of the commands that are happening from the different nodes. So if you just type in show now, you should be able to see that there are two of the nodes that we have set up, the management node and the DB node. Both of them are now running, and now all we need to do now is to configure the API node. Okay, so just like we did in the management node, we are also going to set this NDBD, the NDB daemon, to automatically launch when the cluster launches. So we're going to basically create an init.d script for the same thing. So we're going to say ndbd, and notice we don't need to say initial anymore because we already did that. We just need to do that once. So if you want to launch this server again, you just need to use the command ndbd, and we're going to put this into an init.d script. So just go ahead and put it in init.d/ndbd, and as usual, we need to make sure that there is execute permissions on that file. So let's just make sure that that's the case. All right, so the DB node is now fully configured. Even if you stop or start this instance, it should restart the daemon process as part of the init.d script that we just configured. Okay, so the last node that we need to configure is the API node. And what I'm going to do is in the API node, first we'll make sure we're root. Okay, now that we are root, we're going to create a user and group called MySQL. This is to make sure that the MySQL API node doesn't run anything as root. That's a general security hole. So we want to make sure that we restrict the daemon's capabilities to run root commands. So we're going to run the daemon as MySQL. So I'm going to go ahead and create these two users. I'm going to go ahead and create the user and the group. So first the group add MySQL, and then I'm going to say user add -g MySQL. So, and the name of the user is MySQL. So we're going to create a MySQL user that is part of the MySQL group, and that's also complete. Okay, now similar to what we did in the DB node, we're just going to go ahead and go to user local and download the MySQL cluster binary files. So let's just go ahead and wget and get the tar.gz file. Okay, the download is complete. Now we're just going to go ahead and extract all of these files. Okay, once the extraction is complete, we're just going to go ahead and create that symbolic link as we did in the DB node. So I'm just going to create a symbolic link to this long directory name, and we're just going to call it MySQL. Now we're going to go into the MySQL folder. We also need an additional library to be installed on this instance for the API node. So I'm just going to go ahead and install that, and this is libaio. Okay, once those libraries are installed, let's just go ahead and install the MySQL database by running the actual MySQL database script. So from here, we're just going to, access scripts /MySQL install DB, and we're going to specify the user, which is MySQL, and we're also going to specify a location for the data directory, user local MySQL data. So it's going to go ahead and launch all of the required commands. Now we created the directories that we are using right now. So let's go ahead and make sure that MySQL has the MySQL user actually has permissions to access all of these directories. So just going to say that root and the group MySQL have access to this MySQL directory, and for the actual data directory that we're going to use, we're going to transfer the ownership of that to the MySQL user. Okay, now those two are done. Now we also want to make sure that MySQL, MySQL daemon actually starts up when this instance starts up. So let's create that init.d script. Actually, in fact, we don't need to create it. We already have a MySQL server start script that's provided in support files, and we just need to copy that to etc init.d. And for that same file, we just want to make sure that there's execute permission. So chmod 755 etc init.d / mysql.server. And finally, all we need to do is make sure all the binaries are copied as we did in the other instances. So I'm just going to go ahead and look in user local MySQL bin, and in here I'm going to move everything to user bin just as we did in the DB node. Let's go back. Let's remove the user local MySQL bin. So we're going to remove all of those binary files, and we're going to create that symlink just to keep everything neat and clean. Okay. All right. Now, the final aspect of the configuration of the API node obviously is to create the configuration files. And this is similar to the DB node. We're going to create a file in etc called my.cnf. And again, the actual contents of this file will be available as a link below the video. But it's very similar to the ones that we use for the DB node. So I'm just going to go ahead and paste those in here. Okay, so again, we want to make sure that this API node has the IP address of the management node. So I'm going to go ahead and copy that IP address in here. Okay, and again, we need to make sure that that IP address is available in both these locations in the configuration file. All right. So we've finished the configuration, and all we need to do is basically start up the MySQL daemon, and we want to make sure that the data folders for MySQL are also available. So let's go ahead and create that MySQL. So that's the same location as the one we did in the DB node. This is varlib MySQL cluster, which is going to create that directory. And now what we can do is we can actually just call the etc init.d script that we just copied, and we actually can give the command, which is mysql.server start, and it should go ahead and start MySQL for you. Now there is an additional step that needs to be done, and it is recommended by basically everyone to keep your MySQL installation secure, especially on a server that is public facing like this one. So what we can do is we can simply run this command, which is user local MySQL bin, and then say MySQL secure installation. Now this is going to basically ask you for a password that you can use. So currently we did not set up a root password, so we're just going to hit enter, and we can set up a root password. All right, and it will also allow you to remove any anonymous users and things like that. So we're currently not going to remove the anonymous users, and we're not going to disable root login remotely, or we're also not going to remove a test database. But if you want to make sure this is secure, you have to follow the recommended practices here. Okay, now that we have everything in place, we can go back to the management node to check if all of the instances are running. And as you can see, everything is actually running now. So we have the management node running, we've got the DB node running, and we've got an API node that's also running. So our MySQL cluster installation is complete. You can actually test whether your MySQL installation is working fine. So what I'm going to do is you can just try to log in as root, It's going to ask you for a password. And you should be logged into the MySQL cluster right now. So if you just type in show tables or show databases, yeah, so MySQL is available. Ideally, we've logged in as a root user, but you can actually create a user in the MySQL cluster for you to use and for you to configure any clients that need to connect to it. So we'll go ahead and do that right now. So let's just go ahead and create a user. So let's just go ahead and type in that command, which is create user, and then we'll provide a username. So let's call it like db user at so this is for local connections, so at localhost identified by password. Obviously you don't want to use the word password, you want to use something a little stronger than that, but I'm just using password for this for the sake of this video. We're also going to go ahead and grant all the privileges. So this is going to have privileges granted to this user, which is db user at localhost with grant option. So we are going to go ahead and grant all the privileges to this user. Just going to add the quotes in this command. That's complete. Now we also want to create that user that will connect from any machine. So let's go ahead and create user, in quotes, user at %, which signifies that the user will connect from any IP address, not just localhost. Okay, that's complete, and then we want to just rerun the grant privileges, but for db user. Okay, and then if you simply type in flush privileges, okay, so that's complete.